Azure Messaging Services Documentation, Azure Event Grid, Azure Event Hubs, Azure Service Bus, and Azure Relay. Azure Queue Storage. Azure Queue Storage offers a simple, reliable, and cost-effective way to store large numbers of messages for asynchronous communication between application components. It allows you to decouple these components, enabling them to scale independently and improve overall application durability. While storage queues offer a straightforward messaging solution, it's important to be aware of their limitations, particularly regarding message size and potential performance bottlenecks under high load. Types of Azure Storage Queues. Azure Storage Queues are part of Azure Storage, which offers various storage options for different needs. The main types of Azure Storage include blob storage, for storing unstructured data like documents, media files, and backups. File storage, for providing shared access to files in the cloud, similar to traditional file shares. Queue storage, for storing messages that can be accessed asynchronously by different application components. Table storage, for storing structured, non-relational data, suitable for scenarios like user profiles or product catalogs. Limitations of Azure Storage Queues. Message size. The maximum size of a single message in an Azure Storage Queue is 64 kilobytes. Large messages. While individual messages are limited to 64 kilobytes, you can work around this limitation by combining queues and blobs. With this approach, you can enqueue up to 200 gigabytes for a single item. FIFO, first in, first out. Azure Storage Queues do not guarantee strict FIFO ordering of messages. Message ordering. While messages are generally added to the end of the queue and processed from the front, strict FIFO delivery is not guaranteed. Performance. Storage queues can experience performance bottlenecks under high request rates, or when dealing with very large numbers of messages. Scalability. While storage queues can handle a large number of messages, individual queues are subject to the overall capacity limits of the storage account. Advanced features. Compared to Azure Service Bus, storage queues lack some advanced features like message filtering, sessions, and transactions. When to use Azure Storage Queues. Simple asynchronous messaging. When you need a straightforward way to exchange messages between application components. Decoupling application components. When you want to build applications where components can scale independently and communicate without direct dependencies. Cost-effective messaging. When you need a reliable and inexpensive messaging solution for large numbers of messages. When to consider other options. Large messages. If you need to send messages larger than 64 kilobytes or 200 gigabytes with the blob/queue combination, consider alternatives like Service Bus. Advanced messaging features. If your application requires features like message filtering, sessions, or transactions, Service Bus is a better choice. High throughput and low latency. For scenarios requiring very high throughput and low latency, other messaging solutions might be more suitable. Strict FIFO ordering. If strict FIFO ordering is critical for your application, consider using Azure Service Bus or other messaging solutions with stronger ordering guarantees. Azure Queue Storage is a service for storing large numbers of messages. You access messages from anywhere in the world via authenticated calls using HTTP or HTTPS. A queue message can be up to 64 kilobytes in size. A queue may contain millions of messages, up to the total capacity limit of a storage account. Queues are commonly used to create a backlog of work to process asynchronously, like in the Web Queue Worker architectural style. Queue storage concepts. URL format. Queues are addressable using the following URL format. https://storageaccountqueue.core.windows.net/queue. The following URL addresses a queue in the diagram. https://myaccount.queue.core.windows.net/images to download. Storage account. All access to Azure Storage is done through a storage account. For information about storage account capacity, see scalability and performance targets for standard storage accounts. Queue. A queue contains a set of messages. The queue name must be all lowercase. Message. A message, in any format, of up to 64 kilobytes. Before version July 29, 2017, the maximum time to live allowed is 7 days. For version July 29, 2017 or later, the maximum time to live can be any positive number, or -1 indicating that the message doesn't expire. If this parameter is omitted, the default time to live is 7 days. Azure Event Grid. Azure Event Grid is a highly scalable, fully managed pub/sub message distribution service that offers flexible message consumption patterns using the MQTT and HTTP protocols. With Azure Event Grid, you can build data pipelines with device data, integrate applications, and build event-driven serverless architectures. Event Grid enables clients to publish and subscribe to messages over the MQTT v3.1.1 and v5.0 protocols to support Internet of Things (IoT) solutions. Through HTTP, Event Grid enables you to build event-driven solutions where a publisher service announces its system state changes, events, to subscriber applications. Event Grid can be configured to send events to subscribers, push delivery, or subscribers can connect to Event Grid to read events, pull delivery. Event Grid supports Cloud Events 1.0 specification to provide interoperability across systems. Core features. Here are the two main features of Azure Event Grid. MQTT messaging. IoT devices and applications can communicate with each other over MQTT. Event Grid can also be used to route MQTT messages to Azure services or custom endpoints for further data analysis, visualization, or storage. This integration with Azure services enables you to build data pipelines that start with data ingestion from your IoT devices. Data distribution using push and pull delivery modes. At any point in a data pipeline, HTTP applications can consume messages using push or pull APIs. The source of the data might include MQTT client's data, but also includes the following data sources that send their events over HTTP. Azure Services. Your custom applications. External partner, SaaS, systems. Event Grid's push delivery mechanism sends data to destinations that include your own application webhooks and Azure services. MQTT messaging. Event Grid enables your clients to communicate on custom MQTT topic names using a publish-subscribe messaging model. Event Grid supports clients that publish and subscribe to messages over MQTT v3.1.1, MQTT v3.1.1 over WebSockets, MQTT v5, and MQTT v5 over WebSockets. Event Grid allows you to send MQTT messages to the cloud for data analysis, storage, and visualizations, among other use cases. Event Grid integrates with Azure IoT Operations to bridge its MQTT broker capability on the edge with Event Grid's MQTT broker capability in the cloud. Azure IoT MQTT Broker is a new distributed MQTT broker for edge computing, running on Arc-enabled Kubernetes clusters. It's now available in public preview as part of Azure IoT Operations. The MQTT broker feature in Azure Event Grid is ideal for the automotive, mobility, and manufacturing scenarios, among others. See the reference architectures, automotive and manufacturing to learn how to build secure and scalable solutions to connect millions of MQTT clients to the cloud, using Azure's messaging and data analytics services. Here are some highlights of MQTT messaging support in Azure Event Grid. MQTT v3.1.1 and MQTT v5.0 support. Use any open-source MQTT client library to communicate with the service. Custom topics with wildcard support. Use your own topic structure. Publish-subscribe messaging model. Communicate efficiently using one-to-many, many-to-one, and one-to-one messaging patterns. Built-in cloud integration. Route your MQTT messages to Azure services or custom webhooks for further processing. Flexible and fine-grained access control model. Group clients and topic to simplify access control management, and use the variable support and topic templates for a fine-grained access control. MQTT broker authentication methods -X509 certificate authentication, an industry authentication standard for IoT devices. Microsoft Entra ID authentication, and Azure's authentication standard for applications. Flexible authentication patterns like OAuth 2.0 JSON Web Token, JWT authentication, which is lightweight and secure for MQTT clients that aren't provisioned in Azure, and custom webhook authentication, allows external HTTP endpoints, webhooks, to authenticate MQTT connections dynamically. This method uses Entra ID JWT validation to ensure secure access. Transport Layer Security, TLS, 1.2 and TLS 1.3 support. Secure your client communication using robust encryption protocols. Multi-session support. Connect your applications with multiple active sessions to ensure reliability and scalability. MQTT over WebSockets. Enable connectivity for clients in firewall-restricted environments. Custom domain names. Allows users to assign their own domain names to Event Grid namespaces MQTT endpoints, enhancing security and simplifying client configuration. Client lifecycle events. Allow applications to react to events about the client connection status or the client resource operations. Event messaging, HTTP. Event Grid supports push and pull event delivery using HTTP. With push delivery, you define a destination in an event subscription to which Event Grid sends events. With pull delivery, subscriber applications connect to Event Grid to consume events. Pull delivery is supported for topics in an Event Grid namespace. Push delivery versus pull delivery. The following are general guidelines to help you decide when to use pull or push delivery. Pull delivery. You need full control as to when to receive events. For example, your application might not be up all the time, not stable enough, or you process data at certain times. You need full control over event consumption. For example, a downstream service or layer in your consumer application has a problem that prevents you from processing events. In that case, the Pull Delivery API allows the consumer app to release an already read event back to the broker so that it can be delivered later. You want to use private links when receiving events, which is possible only with the pull delivery, not the push delivery. You don't have the ability to expose an endpoint and use push delivery, but you can connect to Event Grid to consume events. Push delivery. You want to avoid constant polling to determine that a system state change occurred. You rather use Event Grid to send events to you at the time state changes happen. You have an application that can't make outbound calls. For example, your organization might be concerned about data exfiltration. However, your application can receive events through a public endpoint.